Welcome to the tutorial over 8.5, Variation Functions. Your new vocabulary will be direct variation, constant of variation, joint variation, inverse variation, and combined variation. Our first key concept is going to be direct variation. Y varies directly with x if there is some non-zero constant k such that y equals kx. K is called the constant of variation. So for instance, we have y is equal to 3x. K is going to be our constant of variation, which is 3. And it says, and x equals 7, then y equals, alright, so a question like this would say, what is y when x equals 7? And you would plug and chug and get y equals 3 times 7, which is 21. Alright, so what's really important on these questions is that you really look at the vocabulary. It says if y varies directly as x and y equals negative 15 when x is 5, then 5y when x equals 3. Alright, so we know that direct variation, we have y is equal to kx. So what we actually need to do is we need to plug in what we know first. We have y and then we have x. So we're going to plug in negative 15 for y. We don't know what k is, but we do know that x is 5. So what we want to do is we want to actually solve for k by dividing by 5 on both sides. And we get k is equal to negative 3. So now we have our formula, y equals negative 3x. So from there, we can actually figure out what y is when x is 3. You just plug in 3 for x, so you get y is equal to negative 3 times 3. So y is equal to negative 9. If you actually look in your book, they solve it by a proportion, and you can do that as well. I just figured this might be the easiest way, since we gave you a formula on the previous slide, so that way you can use the formula here. The next concept is joint variation. It says y varies jointly as x and z if there is some non-zero constant k such that y is equal to k times x times z. So here's our next formula. So if y varies jointly as x and z, what that means is that you're going to use the formula y equals kxz. Alright, so what's going to happen is that you're going to treat this just like you did the last problem. You'll be given a y, an x, and a z. You'll have to find k, and then have your formula and plug in what you know to get your answer. Okay, so let's try an example. So, example 2, it says, suppose y varies jointly as x and z. Find y when x is 10 and z is 5, if y is 12, when x is 3, and z is 8. Alright, so first you need to look at your vocabulary. It says y varies jointly as x and z. So you actually have a formula for this, which is y is equal to k times x times z. The next thing you want to do is you want to look for your initial information. This has it kind of backwards. We're trying to find y when x is 10 and z, so that's going to be our secondary information. And what we actually have as our primary information is when y is 12, x is 3, and z is 8. So we're going to use these three numbers first to figure out what k is. Alright, so let's plug in what we know. We know y is 12. We don't know k. We know x is 3. And we know z is 8. So from here, we need to find out what k is. 3 times 8 is 24. So we get 12 is equal to k times 24. And then to solve for k, we have to divide both sides by 24. And we reduce this k is equal to 1/2. From here, we know that our new formula is y is equal to 1/2 times x times z. So we can go to our secondary information, which is marked in blue up here, and we're trying to find y, so we're looking for y, when x is 10, so we have y is equal to 1/2 times 10, and z is 5, so times 5. When you plug that in, 1/2 times 10 is 5, 5 times 5 is 25, and that would be your answer. All right, so another concept we're going to talk about is inverse variation. Okay, so y varies inversely as x if there is some non-zero constant k such that we have x times y is going to equal our constant, or you can think about it this way: y is equal to k divided by x. Okay, so if you have inverse variation, you'll use the formula y equals k divided by x. Or you take your x and your y, you multiply them to get your k value. So for example, if we have x times y is equal to 2 and x is 6, we know that y is equal to 2/6 or 1/3. So let's actually try an example. So here it says r varies inversely as t and r equals -6. When t is 2, find r when t is -7. All right, so we have to look at our vocabulary, and it says it varies inversely. Okay, so varies inversely. So that tells me I'm going to use the formula x times y equals k, or y is equal to k divided by x. So it says r, and also in the last slide it says y varies inversely with x. So think about it this way: r is in the y place, so this is going to be, and then t is in the x place, so these formulas are going to change to t times r equals k, or r is equal to k divided by t. Okay? Alright, so we need to plug in what we know. We know that r is -6 when t is 2. So we're actually going to use this first formula so we can figure out what k is. So we have t is 2, r is -6. That's going to give us k, which is equal to -12. So we have the second formula, r is equal to -12 divided by t. And it says we're trying to find r when t is -7. So we're trying to find r. We know that k is -12, and we're dividing by -7. And unless you get a decimal, this is actually as reduced as it can be. So a negative divided by a negative is a positive. So our answer is 12/7. All right, example number 4 says the apparent length of an object is inversely proportional to one's distance from the object. Earth is about 93 million miles from the sun. Venus is about 67 miles from the sun. How much larger would the diameter of the sun appear on Venus than on Earth? First of all, we need to look at what we're looking for. We say that the length of an object is inversely proportional to one's distance. Okay? So length is proportional to distance. So length proportional to distance. And we're talking about an inverse relationship, which, if you remember, inverse would be y equals k divided by x, or x times y equals k. So what we're going to do is we're actually going to use this x times y equals k. All right. So we have, let's see, the Earth is about 93 million miles from the sun, so that's going to be our distance. And it says Venus is about 67 million miles from the sun. That's going to be our second distance. So we have D1 is going to be to 93 million, and we have D2 is going to be equal to 67 million. It says how much larger would the diameter of the sun appear from Venus than on Earth? And we're going to let V1, we don't know what that is, and then V2 would be 1, because these are going to be our diameters. Okay, so this one's talking about Earth, and this one's talking about Venus. All right, so if we actually set these up, we know that K is going to be the same in both equations. So what I'm going to do is I'm actually going to take these two things and multiply them together. So I'm going to get 93 times V1 is actually going to be equal to 67 times 1, because we're using this x times y equals k. And since they equal the same k, that means we can actually set them equal to each other. Kind of weird, I know. Let me just rewrite this over here real quick. Oops, I accidentally got that backwards. This should be a, we don't know. Let's see, this should be 1, and this should be, we don't know. So let's actually switch that real quick over here. Let's see, we're going to get 93 times 1 is equal to 67. Let's just say x. That's easier to see. So if we take this and divide by 67 on both sides, we get our x is equal to 1.39, which is actually my answer. All right, last example, we have suppose that f varies directly as g and f varies inversely as h. So let's think about these. F varies directly, so that means it's going to be the formula k times g. And then it says f varies inversely with h. So that would be the formula f equals k divided by h. So what we're actually going to do is we're going to put these two things together. K is the same in both of these, except when we put them together, it's going to be f is equal to k times g divided by h. Okay, so this is going to set up our formula for us. And the first thing we have to do is we actually have to solve for k first. Okay, so we actually have to use, let's see, it says find g when f is 6 and h is 5. So this is going to be our secondary information. And here, this is going to be our primary information that we have to use first. Okay, so let's plug and chug. We know g is 18. So we have k times 18 over, we know h is 3, so divided by 3, and we know f is 5, so equal to 5. And we need to actually solve for k. All right, so first let's do 18 divided by 3, which is 6. So we get 5 is equal to 6k. And then divide by 6 on both sides, so we get k is equal to 5/6. All right, so let's go back to our formula. We have f is equal to 5/6 times g divided by h. All right, so now we need to plug in our secondary information to figure out what g is. We know that f is going to be 6. So 6 is equal to 5/6 times g divided by, we know h is -5. All right, so let's solve for g. We're going to multiply by -5 on both sides, so we can get rid of the denominator. And we get -30 is equal to 5/6 times g. The next thing we're going to do is we can either multiply by the reciprocal, or we can just take this and divide by 5/6. And when you plug that in, you're getting g to equal -36, which is your answer. And that concludes 8.5. Thanks for watching.